today's session we discuss about the stress strain curve and Poisson's ratio. Okay, let's say start with the first one, a stress strain curve. Stress strain curve. So in a stress, it means you draw the graph between the stress and strain when you apply some force on a body. Okay, suppose you consider you have this type of body, and so this is the one road, and you apply some force on the body, and you just change the force, applied force on a body, and you draw the graph between the stress and strain. Then the graph is named as a stress strain curve. Let's see, suppose you draw the graph of sigma versus epsilon. Then which type of graph we have to draw here? So initially when the force is smaller one, the stress and strain both are directly proportional to each other as per the Hooke's law. Okay, so initially this is represents a straight line from, consider this point O to this point A. So when this force is up to some limit, okay, then the stress is directly proportional to strain. So that is a Hooke's law. So graph O to A, that here it is a sigma is directly proportional to epsilon. That is what, this is a Hooke's law. And this point, up to this point A, there is some proportionality limit is applicable. After this, proportionality limit does not applicable. Okay, so O to A, here the elastic behavior, here the body having some elastic behavior. Okay, after, see, if you remove this force between the O and A, then the object is again comes to its original shape. But now you increase the force, now you again increase the force, then what happen? Then the stress does not directly proportional to strain. So after this, if you change the force, then this behavior is like this. Okay, so this point is a B and this point is a C, consider. So after A there is some non-linear behavior between the stress and strain. Okay, so this type of the situation is given to us. If you remove the force at the C, if you remove the force at the point C, then there is some permanent deformation. Okay, you just draw the figure like this, so your idea will be clear. Here there is a body gets some permanent deformation. See, so here body gets some permanent deformation. So this is the permanent deformation. Okay, and this deformation is generally less than 1% of the original one. Okay, but if you remove the force before A, then body gets its original shape, but you remove the force at C, then there is some permanent deformation. And this point point A is named as a proportionality point. Okay, so point A is represents here proportionality limit. Proportionality limit. After point A, proportionality does not applicable. Thus B is a elastic limit. Thus point B is what? Elastic limit. Then after the plasticity behavior of the body comes into the picture. C is a yield point. C is what? There is a yield point. There is some internal structure of the body is changed. After B, the internal structure of the body is what? Change. Okay, and then after again you increase the stress, then what happen? There is a large amount of change in a strain with the small change in strain. See, initially the stress is very large, the strain is small, change in length of the body is smaller one. But after point C, if you just take a small change, after point C you just take a small change, then there is a large change in a strain. Because how much stress is changed? See, this much stress is changed, but how much strain is changed? Strain is produced much more. Okay, so consider this point is supposed to be D. So D, at the point D there is a maximum stress. At the point D there is what? Maximum stress. So D is point name as a maximum stress. That is a maximum stress, or we call it is breaking stress. We call it is breaking stress. If you apply some force on a body and the body reach at this point D, then body must be the break after this point. Okay, and sometime we also call it is ultimate strength. इसको क्या बोलते हैं also ultimate stress. Okay, that is a maximum. After this point body must be break, and if you extend the graph up to someone up to this point suppose, then at this point E the body becomes break. It means it is fracture point. What is this? This is named as a fracture point. So point E is named as a fracture point. But once a body is reaches the point D, there is a body must be break. But after some elongation, the body is completely break at the point E. So this point E is named as a fracture point. So this one is known as a plastic behavior. This one is known as a plastic behavior of a body. Okay, so this is the simply known as a stress strain curve. Initially the stress and strain directly proportional to each other up to some limit, that is a point A, and this point A is a proportionality limit. Up to this point A the Hooke's law is applicable, but after the point A Hooke's law does not applicable. Then after the you increase the stress, the strain is also increases, and at the point C, when the body reach at the point C, there is some permanent deformation is produced on a body which is less than 1%, but again you increase the stress, strain is continuously increases, and but after point B, that is elastic limit, the body does not comes back to its original shape. Okay, so up to this point B, that is elastic behavior, and after this one, that is a plastic behavior. And when the body reach at the maximum stress condition, it means breaking stress condition, body is break after the point D, and this E is a fracture point. Okay, so everybody note this. Then after we come to this next one. Let's say this next topic is Poisson's ratio. Poisson's ratio. Okay, and this is denoted by mu. The Poisson's ratio is denoted by mu. So what is this actually? So ratio of lateral strain to linear strain called Poisson's ratio mu. इसको हम क्या बोलते हैं? Poisson's ratio. So mu is denoted by simply lateral strain to linear strain. What is the meaning of this? You understand? Let's see. Suppose you have a one body like this. You consider you have this type of body. You apply some tensile force. आपने मान लो कि यहाँ पे कुछ टेंसाइल फोर्स, टेंशन अप्लाई किया, फोर्स अप्लाई किया, मतलब you apply some force, so its length of the body is changed. So when the length of the body is changed, its diameter is also changed. When the length of the body is changed, it means there is a diameter of the body is also changed. So there is a new condition. Suppose this here we consider the length of the body is increases, the diameter of the body is what? Decreases. So linear stress means what? The strain produced along the force, and lateral means a stress produced perpendicular to force. Okay, so right now we apply the force along the length. हमने लेंथ के along इसका लेंथ के along force apply किया है. Let's consider suppose original length is L and original diameter is supposed to be D. So here right now in the situation, the lateral means linear strain means what? Linear strain means strain produced along the force, and lateral strain means what? There is a strain produced perpendicular to the force, produced perpendicular to force. Okay, let's we continue our session with the derivation of this one. So how we write this equation? So how much change in diameter? Suppose consider it delta D. So thus mu is equal to delta D upon D, that is a lateral strain, upon what is the change in length? Suppose delta L, then that is a delta L upon L. But Poisson's ratio is always positive, it's never negative. it's always positive. So here diameter is decreases, length is increases. It's opposite case. Suppose the diameter is increased, then means length is decreases. So we put our negative sign here. This negative sign indicates thus D and L both are oppositely changed. Means one is increases, another one is decreases. In magnitude term, that is always positive. So we put the one additional negative sign. या फिर आप ऐसे भी इसको लिख सकते हैं, thus mu is equal to mod delta D upon D divided by delta L upon L. This is also another way to write the Poisson's ratio. Okay, so that's one. What is the negative sign indicates here? Negative sign indicates the length increases, diameter decreases. Okay, so negative sign indicate length increases, then diameter decreases. So finally by the using of negative sign you get the positive answer. Okay, and some additional notes for this Poisson's ratio. Out of this, first one is what? Maximum value of the mu is equal to 0.5. It's never greater than 0.5. Maximum value of the mu is what? 0.5. So it's vary from 0 to 0.5. So we can write down 0 less than mu less than 0.5. मतलब mu is always less than 0.5. वैसा आप याद रखो. 0 it's vary from 0 to 0.5. Mu is vary from 0 to 0.5. Okay, some MCQs which is asking to you based on theory, so you must be remember this value. If you consider the steel, so for the steel mu is vary from 0.28 to 30. Okay, so mu is in a range of 0.28 to 0.30. And if you consider the aluminium alloys, then mu is approximately 0.33. So this is the some basics one which is we have to discuss here for the Poisson's ratio. And you must be remember this whole theory properly. Sometimes it is helpful in to solve out the different problem which is asking to you in the form of MCQ. Okay, chalo, not this